suppose a wooden block of mass 50 kg and it is traveled above the earth's surface about 30 meters, then we will be calculating the potential energy as mv. That is F into S, that is F equals to ma and ma equals to mg, because A equals to g, therefore mgh is the potential energy, and the mass is 50 kg and g is 9.8 meter per second and h is 30 meters. Therefore 5 3s are 15 and that is 1500 into 9.8, that gives us 8 5s are 40, 8 1s are 8, 8 plus 4 12, and at the same time we will be calculating with 9, that is 9 5s are 45 and 9 1s are 9 plus 4, that is equals to 13, and when we add these two we will be getting the answers such as 5 plus 2 7, 3 plus 1 4 and 1. Therefore keeping the point after 1, that is equals to 14700 joules, right? That is 14,700 joules of energy consumed in order to lift a 50 kg above a height of 30 meters, right? In this manner, we will be calculating each and every energy consumed or the work done by an object, either that is potential or kinetic energy. Now let us see the law of conservation of energy and its principles. Let us see, are various energy forms inconvertible? That means, can we convert one energy form into another? That is the meaning of the statement, right? Now let us see some examples in order to understand the conversation or transformation of energy between each other. That means, suppose, do you have any questions such as how the plants prepare their food, or how the plants goes on in photosynthesis process, and at the same time how the air is moved all around, and how the fuels formed, that is coal, mines, iron, and how these elements are formed under the ground, under the earth. Let us see all these points in brief. That means the energy is transformed, that is the plants will be observing the sun, that is from sun, that is light energy, and at the same time they observe the oxygen, waters and all from ground, earth, the nutrients also from earth, from the soil, right? And let us see that the fuels are composition of some ores particles underneath the earth, right? That means what I mean to say is, that is the energy is transformed between each other, that is the energy is convertible. Suppose I am introducing or I am keeping as some input, or that is energy on this pen in order to open the cap, right? That cap is open. The energy I kept, the resultant is the opening of the cap, right? And at the same time the conversion of the electrical energy to mechanical. When we keep diesel, right, the generator runs, that is the transformation of mechanical energy into electrical energy, right? And at the same time when you give electricity, that is power to the any fridge or anything, mixer, grinder, all these things, when we give the electricity power as the input energy, the machine starts running, that is the motors inside the machines, that is washing machines, ACs and all, and thus it is converted into mechanical energy. In the same manner, the heat energy is converted into chemical, and the light is converted into heat, heat is further chemical, and in a way, what I mean to say that energy is transferred or changed between the objects, right? One form to other. But wherever you can see that energy is not at all created, and we cannot destroy the energy also because it is changed into another form, right? Therefore, we can say the definition of energy like this, that is, energy is neither created and not destroyed. Now let us see the law of conservation of energy, that is, energy can only be converted from one form to other. It can be neither destroyed and nor created, right? This is the law of conservation of energy. Now let us see the potential energy and kinetic energy. The summation of potential and kinetic energy gives us the total mechanical energy. And let us take a good example that when an object is falling from a height, let us suppose from a building top, it consumes potential energy, right? There the kinetic energy will be 0 and potential energy equals to mgh, right? When it attains the position on the earth, that is the rest position, it tries to move on the earth, then the potential energy becomes 0 here and the kinetic energy starts, that is half mv square, right? That means what I mean to say that previously potential energy is there for a stone, right? When it falls on the earth, it is moving on the earth, then it attains kinetic energy, right? Therefore the potential energy transformed into kinetic energy, right? So we can say that the transformation of energy taken place here and there is no creation or no destruction of energy here, right? So we can say the potential energy plus summation of the potential and kinetic energies is constant, right? Therefore we can say the rate of doing work. Let us deal with the point that is rate of doing work. That is, let us take two persons of same weight, that is 30 kgs, and if one person is getting up, that means one person is running, then we keep a running race, one person will be reaching the destiny within 15 seconds and another takes around 30 seconds, right? What is the difference? Both are having the same weight and same mass, but the difference is one might be stronger and one might be weaker. So one may be a strongest person. So the destiny reaching will be different. That means the time taken by a person to reach the destiny changes from one person to another. And if at all the work done by each person, right? I can be doing very good, but some cannot be, right? Means I can study well, other person cannot study well. That means the difference of categorization of doing work that relates to the time. Therefore, in how much time, how much effort they are giving, how much input they are giving. That is the categorization of rate of doing work, right? If at all I can read 10 newspapers within 1 hour, someone can read only 5 newspapers. That means the time is calculated. According to the time, with respect to time, the work what we have done is calculated, right? Therefore, we can say the rate of doing work is the time taken to do a particular work within a time is known as rate of doing work, and the term is known as power. That is the power. Now here we understood the clear difference between the work, energy and power. Work means the ability to do work, that is the energy what we consume in order to do a work, that is useful work and not useful work, right? Work means according to science, that is the force applied to move a particular distance of an object, and at the same time energy means the consumption of work. That means the rate of doing of work is known as power, and at the same time power is defined as work by time, right? And the 1 kilowatt equals to 1000 watts, and the James Watt is the scientist who defined the units for power. Therefore the unit of power is watt, that is denoted as with the symbol W, and 1 kilowatt equals to 1000 watts. And let us say the commercial unit of energy, that means watt is a very small unit, right? We cannot compare big things with that small unit. The commercial unit, that means for example, let us take electricity bills. That is 1 unit equals to 1 kilowatt hour. We will be measuring there, right? If we consume 32 units of power, then that is equals to 32 kilowatt hours. That is kilowatts of energy, electricity consumed per hour. Now let us see that the 1 kilowatt equals to 1 kilowatt into 1 hour, and 1000 watts 1 kilowatt equals to, right? 1 hour equals to 3600 seconds, that is 60 minutes equals to 60 into 60 seconds. Therefore, we will be getting 36. After that 5 zeros, that is, we will be getting around 36 lakhs, or that's 3 crores 60 lakhs, right? And this is the unit for 1 kilowatt hour, that is 3650 joule. And we can say that as 3.6 into 10 to the power 6 joules of energy. energy, that is 1 kilowatt equals to 3.6 into 10 to the power 6 joules, and 1 unit equals to 1 kilowatt hour. This application mainly we will be using in electricity bills, right? And let us see some problems regarding these two concepts.